So we have a circuit, means circle. It goes through the batteries, through the conductors, through the light bulb. The energy going through the filament makes the light bulb light up. The instructions say to test copper rod. So we're going to put it in the circle, or in the circuit. Copper rod, zinc, the carbon of a pencil. This is 1.2, filtering a mixture. So we have a substance in a jar. Add 10 milliliters of water. Rubber stopper. Agitate. We're going to filter. Fold the paper in half. Fold it in half again. Pull one side loose. Put that in the funnel. We're going to pour this mixture into the funnel. I'm going to agitate a little bit first. A lot of the solids stayed in the bottom, but some of them were dumped into the filter paper. And notice that the material coming through the filter is a clear liquid. The solid materials, whatever was poured in there, are left in the filter paper. This is 1.3, the burning candle. Notice that when we begin, the candle is completely solid. We have evidence of energy release in that there is light being emitted. There's also some heat. And there's one other interesting thing, if we can give it just a minute. The solid wax at the top of the candle is becoming a liquid. You may be able to see it dripping right here. And the instructions say to cover with a beaker. Notice that there's a fog. Now there's smoke. The light, the burning went out. There's some smoke coming off of there, but there was some moisture. That's actually water vapor that is condensed on the inside of the beaker. That was 1.3. 1.4 is called separating the mixture. You have a powdery mixture. It is yellow with some dark spots. And we have a magnet. There's actually two magnets here. I'm going to take one off. And if you'll notice, some of the particles are magnetic. The magnetic particles stick to the magnet. The other particles don't. So we're able to separate materials based on the property of magnetism. So the yellow powder is not magnetic. Whatever these black filaments are magnetic. (1.5) is called adding the acid. Let's get our angle a little better here. In each of these test tubes, there's approximately 10 milliliters of hydrochloric acid. It's HCl, and there's some water in there, so it's actually a solution. Those have already been measured and poured in there. One thing, the paper asks us to feel the test tube to see if there's a temperature change, and I can't get you to feel this through the camera, but I can stick a thermometer down in there, and right now this thermometer says 20 degrees Celsius. We're supposed to add one piece of magnesium ribbon, which is a metal. It's a very thin piece of metal. We're going to drop that in there. And we're supposed to observe what happens. Let's see if we can zoom in for just a second. So we can see gas is being produced. There's a lot of little bubbles there. If it was quiet enough, you would be able to hear a little bit of a sizzling sound. Sound is a form of energy, so there's energy is being released. Also, if you look very closely, you may see what looks like a little bit of steam there. And if we look at our thermometer, I don't know if the camera can see that or not, but the thermometer is up to 25 degrees Celsius already. So there's energy being released by this chemical reaction. The next test tube, we're supposed to add a small amount of zinc granules. Zinc is a metal. It's a gray metal, looks silvery. I'm going to take just a part of a lab scoop and add it to the second test tube. Close up my containers. One thing you'll notice, the magnesium ribbon appears to have almost completely reacted. There's still a tiny bit left in there. The temperature is now 28 degrees Celsius. But look what's happening with the zinc metal. Let's zoom in on that. You can see that there are some very tiny bubbles occurring. There is a chemical reaction going on because gas is being produced. However, there is a difference in the rate of reaction, partially because of the shape of the material, partially because of its position on the periodic table. Okay, that was 1.5. (1.6) is called comparing two mixtures. We have 10 milliliters of water prepared for each of these test tubes. We're supposed to put one scoop of each of these substances. F is a fine white powder. So there's our F. E is a grainy red and white powder. And we're supposed to add 10 milliliters of water to each. This is 1.7, reacting the tablet. This one's rather simple. We start out with taking the temperature of the water ahead of time, and right now this water is, let's just say 19.9 Celsius. We take one of the tablets and we drop it in the water. We can see that gas is being produced. That's evidence of a chemical reaction. And we're going to have a little bit of an overflow there, which is fine. We'll get some paper towels. So gas is definitely being produced, and if we are able to see very carefully, the temperature has quickly gone down to about 18 degrees Celsius. So a temperature change is also an indicator that a chemical reaction has taken place. This is called 1.8, mixing the solutions, and it says to carefully measure out solution G, 10 milliliters, and then match the amount of solution H in the second test tube, and it says to mix the two. So we started out with two clear solutions, and we end up with a solution that looks a little bit like old milk. The white material inside is actually a solid. Then we're supposed to take our filter paper, fold it once, fold it twice, insert it into the funnel, and then we pour our mixture of solid material and whatever rest of the solution is in there, and watch what happens under the funnel. This one comes out rather slowly, but you can see that the only thing in the bottom of the test tube is a clear liquid. The solid materials have stayed in the paper of the filter.